Okay.
A paper right? Otherwise,
Guys, can you go for a mute if you're talking with someone? Okay. So first thing you need to understand who and all, what are the cloud provider that providing a Kubernetes? AWS, what is the Kubernetes cluster name? We used to EKS. Sometimes they will ask,
EKS.
huh, if it is a Azure, then AKS, correct? If it is a Google Cloud, then GKE, correct? Google Kubernetes Engine. We have a three cloud provider major across the globe, which has a Kubernetes, which provide a Kubernetes as a service. Okay, software as a service. Okay. Now, so Kubernetes can be deployed on VM also. Means Kubernetes cluster means that's what are the component they do have, what are the software they need as a layman. It can be deployed on your Linux VM also. Linux VM also. Only prerequisite has to be installed on the server. It will become a Kubernetes cluster, and it will not act as a EKS. It will act as our own cluster, own Kubernetes cluster. Okay, so everything will be managed by you, but it is very complicated. Okay, so we can also install that Kubernetes component on this master node, worker node. Okay, now coming to that, why Kubernetes is more popular? Any questions? Any idea?
Because of the scalability.
Huh. Because Kubernetes has a auto scaling and auto healing feature. Auto scaling, you can scale up your environment and you can scale down your environment. Means that suppose today in Amazon, just to think there is a business is growing. Okay, they have a sale, yeah, something like that. Okay, now so they are not expecting every minute 5,000 requests will come. So now 5,000 requests is coming. So they have cluster now again 10,000. So application will go down, right? So what they use to when you have a Kubernetes cluster, you can scale your environment. Okay. So when CPU goes 70%, I can scale to one more cluster, one more application server. If it is 80%, two more, something like that, you can scale. When traffic goes down, you can scale down the environment. Okay, so that is the main benefit we have for Kubernetes cluster. Okay, nowadays 90% of organization they are using Kubernetes cluster. Okay, in Kubernetes cluster they have a in the architecture it should be one master and two worker. It should be in one master, two worker. Two worker node means this is your, just to think, this is your worker node 1, this is your worker node 2, and this is your master node. Means this is your brain. Okay. And they have a one master, two worker. One master and two worker, which is your minimum, bare minimum. Okay, this is a minimum to become a cluster. You should have a one master, two worker. Apart from that, you want to scale for 4, 5, something like that. You can scale. You can scale up and you can scale down. Okay, like this you can scaling. You can do the scaling. Okay, first thing. Okay, so first let's understand that Kubernetes architecture. So I will put this PPT. Okay, so Kubernetes is a open source container orchestration platform that automate the deployment. And we talk about scaling, right? You can scale your environment, management of containerized application. It is essentially manage a group of computing nodes called a cluster, which is run containerized application and providing tools, deploy, scale, and manage them. Okay, so basically, if you talk about for Kubernetes, right? Basically, you can scale your microservice based containerized based application like anything, and you can scale down your application based on requests. Suppose now I have in night we have only 100 requests in my application. Do I need a 4 worker node? No, it will get a scale down. I need only minimum, bare minimum. Again our traffic goes high from 9 o'clock, again I'll scale my environment, something like that. Okay, so EKS, GKE, or AKS. These are the main Kubernetes platform provider who provide these services. Okay. Now, if you talk about Kubernetes features, so we have auto scaling, lifecycle management, declarative model, okay, self-healing, storage, load balancing, DevSecOps support. These are the things that's providing that. I have mentioned everything. So let's understand the architecture. So you see, we have one master, two worker, correct? So this is your EKS cluster on AWS side, and we have how many? One master, two worker, and you can connect your cluster using AWS CLI. So to connect your cluster, right? Suppose this is my server, this is your laptop, right? From laptop to Kubernetes cluster, how you can connect? Via AWS CLI. You can create your cluster using EKSCTL and kubectl. So this you see that EKSCTL and kubectl given by EKS, right? And AWS CLI is a AWS component, which you can connect that AWS services. Okay. So everything will be installing that. Okay. Now coming to the architecture. So if you see this architecture, which has one master and two worker. You see this, right? You have a master node. This is your worker node 1. This is your worker node 2. In master node, what are the components we have? Master node, just to think like, is the brain. Okay. And master node has a component which have your API server, controller, scheduler, and etcd database. Okay. So API server is the front end of the control plane. Okay, is a brain, you can say, and they control plane and only component that control plane that we interact with directly. So anything you want to connect, suppose you want to put your hand from your somewhere to laptop, who is giving you a response? Brain is giving you a response. Yeah, I want to see same like API server is a brain front end of this control plane. We interact with directly. You have to interact with anything you wanted to do. You have to interact first with API server. Okay. Internal system component, because it's an internal as well as external user component. So anyone want to connect, they have to connect via API server. Any questions? Okay. And all communication will happen same via API only. API server only. Okay. This act as a middleware between master and control plan component and node and worker node, because it's a middleman. Okay. So anyone, just we used to call mediator, right? So anything, yeah, any of the components want to connect something, need something, right? Whenever something memory got, yeah, pod goes died, yeah, application goes died, and they want to, whom they have to interact? API server. Hey, this application pod went down. Now API server, and everyone is connected to API server. You see that, right? Controller, scheduler, etcd, who are and all connected. Everyone is connected with the API server, right? Even developer want to connect API server. Something you want to create, then you have to interact with API server. So now everyone is connected with API server. So something goes down. This guy, when data comes, this guy will come to know. Suppose this guy will come to know, this guy will come to know, and then it will send the request to API server. It will go and create them. Something like that. Okay. So now API server, you understood? What is API server? Everyone? If you see the architecture, API server interacting with your worker node, okay, which is your kubelet. Kubelet is an agent which check whether pods are running, and it will running or not on this worker node. So it will interact. So now you see here. Now suppose this pod goes down. It will send the information. Kubelet agent will send the information to, hey, this pod went down. Now API server has information. All three guys, etcd, controller, scheduler, are connected with which API server. Now when they pass the information to API server, and then scheduler already connected with them, they'll come to know my product goes down, my activity, and so now I need to do some activity. So what they'll pass the information to API server, and then they will go and create them. Something like that. Okay. So now we have a API server. So API server is the middleware between master and worker node components. Now controller. The role of the controller is to obtain the desired state from the API server. It checks current state of the nodes and a task control determine there are any difference, resolve them with the help of scheduler. Okay, so controller, what they will do, this controller guy, what they will do is, this guy, it will check the desired state of the cluster. If something goes down, then scheduler will, they will pass the information to scheduler. You see, right? Resolve them with the help of scheduler if anything goes down. So scheduler watch new request coming from the API server. Suppose now I have to create one more pod and pod goes die. Yeah, I need to restart my container. Everything will happen automatically. So what will happen is, now this goes down again, it will come to the information to API server, from worker node to API server. This application goes down. Now so controller will take the desired state of the API server from the API server. If something goes down, scheduler will come to the action and they will send a request to API server, and API server will go and create that node, create the pod, whatever things, scale the environment, whatever. Understood? Key value, store it is like a database. Okay, use backup all cluster data. So whatever the information they do have, it will store as a key value pair. Okay, all the cluster data it will store as a key value pair. Understood? Any questions? You understand that now? So you see, API server interacting with scheduler, interacting with controller. Now all the information will go via API and via CLI, yeah, UI, whatever thing, and then you go and create them. Okay. Now there is a network proxy and kubelet. Kubelet is an agent which will install on all the worker node. All the worker node means whatever the worker node, suppose you have created a 3 worker node, so it will go and install kubelet is the agent which you can install. It will be running on all the worker node. And there's a kubeproxy. Kubeproxy is the agent which will running. Kubeproxy is manage your network rules on the all the from worker node to master node. Understood? Any questions? Vasu, Srini, Gajala.
So kube proxy, you said, right? So that is, can you repeat that? So it's
Kubeproxy, yeah, used to call network proxy. It will manage your all the network rules. Okay.
okay.
Okay. Kubelet is an agent which will check whether pod is running or not on the worker node. Understood?
Okay.
Kubelet is an agent which will be running on all the worker nodes, and their work is to check whether pod is running or not. If this pod goes down, then it will send the information to API server. Okay, so API now and controller will check the desired state of the components cluster, and now it goes down. So now scheduler will assign that task. Now suppose this has a out of memory issue, then it has to create here, yeah, it has to create there. That scheduler will decide. You cannot decide it has to go and create here worker node 1 only. Only scheduler will decide. It will go and create there. Okay. User cannot decide like, okay, I want to this pod goes on, so I'll create. Next time it may create here also. Here goes down, right? It will not create here, it will create here. There is a chance. So a user cannot decide, scheduler will decide. Understood? Under the pod, container will be running. Inside the container, there will be a microservice, okay, which is your application. So inside the pod, it can have one container. Yeah, it can have more than one container. Understood? Any questions? No? Yes, no.
So pod is so under the worker node, there's a pod. Under the pod,
there will be a
this
container.
Okay.
Inside the container, there will be a microservice, which is your
So
application.
inside the container is microservices. I'm just
Yeah.
comparing the Docker Compose and this one. So
Yeah. So Docker Compose has a Docker container. Here you cannot go directly container. You can log into the container, which is fine, but you can check the pod status. Pod is running, container is running. Equivalent. Is pod down, container down.
So when it is doing the scalability, right? So IPs and all that configuration changes will like change, right? Because it will like as soon as whatever like the pod comes up, like maybe spin up and come up. So
Everything managed by them only. Okay, so you need to because what has to be exposed and what has to not expose, right, that is managed by cluster, right, everything. So what pod is got created, yeah, pod goes down, another pod is getting created, that we are not exposing, right, exposing your cluster IP, which is your load balancer load balancer details, so that people can access from there. But in backend what is happening, you will not come to know. Okay, when you do the troubleshooting, then only this IP and that IP.
okay, like why I was stating the instrumentation, right? When we are trying to do instrument, they ask all this information before, like the application team provides. Okay, this is the IP. I'm sure this is like a dynamic one, not the static, because it changes, right?
Keep on changing.
Keep on changing, so we cannot follow with the IPs then.
That IP you cannot follow with them. Pod
Yeah,
IP, why you need?
so it should be okay. How about the microservices?
See, everything will be having a something called load balancer. Okay, yeah, you need to forward that gateway so that you can have that IP and you can address that. You can log into that. Okay, I'll show you that when
Instead of
instead of pod we are not exposing. You need to expose that cluster and their load balancer details. Okay, so that will
yeah,
people can access.
got it.
Okay. So now, so you see cluster, then we have a node, then pod, container, then we have a microservice. Okay. So I'm not going in depth. There's many, okay, but you understood that. So now to create a cluster. So Kubernetes cluster can be created two way. One way is if you are not aware of much Kubernetes, then I will recommend you go with EKCTL. EKSCTL. EKSCTL command. EKSCTL is a software. With the help of that, you can create a cluster. And second one is manual. Manual means you have to manage all the subnet, everything in the proper way. Then you can create. But I will go with EKSCTL. Why? Because it is easier for you guys. Suppose you want to do the POC or something, right? And you want to understand that, then Kubernetes concept, then and you want to deploy application, you want to deploy Dynatrace one agent, because your responsibility is only install Dynatrace one agent and come out, right? And check that everything is running or not. If you are a Kubernetes admin, then there is a complete responsibility is yours. But if you are a Dynatrace observability consultant, then your responsibility is only to connect to the cluster, install Dynatrace one agent. If it is once it is getting installed, check that all things are running as expected or not. Then you come out. Your work is done, right? But if you are a Kubernetes cluster guy, DevOps guy, or something, then you have to do a lot of activity. That's fine, but for as observability, you should understand how you can create a cluster and then how you can deploy Dynatrace one agent, how you can deploy applications. Okay. So let me show you that. So so I will be using EKSCTL. Okay. So one second, let me go to my browser. Let me know once my screen is visible. So I am creating because all the component, right? AWS CLI, EKS CTL, Cube CTL, everything I will be deploying that. Why? Because you might not be aware of that, how it can be deployed or something like that. So I will be using that. So I'm using one Amazon Linux. This just I'm guessing this is my jump server. You can install in your laptop also. Okay, just wait for a minute. This is my jump server. Okay, where I will be installing all the components. So 23 is fine. I'm taking not bigger one virtual CPU, 2 GB of RAM, which is suffice. And then from that, I will be creating cluster. Okay, DT training. This default launch. if you see on the EKS, so in the EKS, there is a auto mode. Means now Amazon also has some kind of AI. You know that, right? So when you create a cluster, right, from here, when you search EKS, create a cluster, there is a EKS with auto mode. Means that when you go with auto mode, auto scaling also you should not care about that. You no need to care about auto scale also, because now AWS will decide whether I need to auto scale or scale your environment or not. Even you do some custom configuration, and if you enable AKS with auto mode, means their pricing is different because auto mode, because the auto mode means now AWS will decide. Suppose you did that scaling for next 2 worker node. I have a budget, I can add next 2 worker node. Now traffic is more high. Again, 5th node, 6th node will not create, right? Then again, application has out of memory issue, all those things, and pod will start getting down, right? So now if you go with EKS auto mode, if it's 100 of cluster, 100 of worker node required, EKS will auto mode will decide. Now AWS will decide whether I need to go with 100 worker node. So if you go with this, so that are the options we have. Sometimes in the interview, they might ask you, okay? And when you go with EKS auto mode cluster, right? Your server, because worker node will get created as a bottle rocket server. Anyone heard about this bottle rocket?
That is in that plugin, right?
No, that is some kind of server. When you create a EKS cluster manually with auto mode, it will create a bottle rocket server. Just like Amazon, right? Same way, there is a new server, I'll show you that, which is your bottle rocket. I'll show you that. So don't get confused, because sometimes just to type EKS, you see here, Amazon Elastic Kubernetes Service. Again, Dynatrace. Yeah, okay. So now, if you see this, meanwhile, let me log into my server. You see EKS on bottle rocket. So don't get confused, okay? When that server got create cluster, so whenever you deploy, right, once cluster got created, check whether auto mode is enabled, then you go with EKS on bottle rocket. It will create a bottle rocket server. If you go bottle rocket, you see this is not supported. You understand that? Sometimes in the interview they used to ask. You don't know, right? Because they have added EKS and EKS on bottle rocket. Definitely there is a difference, am I correct? So you see, they support only platform monitoring and application observability. Full stack observability they don't have. So this is second one is for bottle rocket. You understand that? Configuration is different means definitely there would be a different. Okay, yeah, go ahead.
So in the bottle rocket, I don't see the full stack. So there's no full stack supported by EKS bottle rocket, right? So but we have the observability application.
You see, even infrastructure observability not supported. Even
so
in this, so there is a difference. If you go with the EKS, right? EKS, you go with this, anyone. So if you go with this platform monitoring, just cluster, resource, topology, metric event, application and infrastructure will not get visible. If you go with this, infrastructure will be not get visible. Means your worker. If you go with this full stack, host, process, everything will get visible. Okay. So that is the concept we have. So now I have logged into the server, sudo space su. So first, to connect your AWS service, what I have to install? First, I wanted to connect from this server to my AWS, right? So what I have to install? Anyone has idea?
AWS CLI.
So first thing, to any service you want to connect, okay, first what you have to install is AWS CLI. So yum update -y, let me update the binary. Okay, now let me go here and add this. So this is the command to install your AWS CLI. This is for Linux. Okay, so if you talk about Windows, install AWS CLI on Windows, there is a command. Okay, if you open this, there will be a choco command, there is a zip file, whatever things, right? See Windows. So you can run this, anyone. Yeah, you can download the MSI, download and run this MSI package. Okay, so first thing, so once it is done, so now what I have to do, ls. So you see, so first to zip the zip file, to unzip, what is the command? Unzip aws cli dot zip. So I am unzipping the file. It's a zip file, right? You are extracting it. Same thing you can install on Windows also. Okay, because in my Windows already installed. Okay, and if I'll create a Windows VM, it takes time, because Windows takes time, have some patience. That is the reason I have not chosen Windows, I have chosen Linux. Okay, but same way, just you have to try, you can try your uh, installation. Okay, now I need to install that. Okay, so I need to run it sudo /aws, okay, /install. Under AWS there is a file, you can run this. So it is done. Now you type AWS --version. Now I'm getting AWS CLI 2.25. If you do now AWS configure, see, I'm asking access key and secret key to connect your AWS services. Now, after that, once you added access key, secret key, regions, all those things, now any service you can connect from this AWS CLI. So CLI is nothing but to connect your services. Okay. So I'm not putting right now. Once this is done, now what I have to install? For Kubernetes, what are the components you have? kubectl and EKS correct? So for kubectl, I am going with this. So ls giving the chmod, then moving my kubectl to this directory, so that from anywhere you can call. Okay, because here somebody can delete also, right? Now if you do this, you see I got this Kubernetes version. Now what I have to install? EKS CTL. So EKS CTL, I can run this. So there is a tar file. Okay. So ls, you see EKS tar.z. So we have done that. So we have EKS Okay. Now moving to EKS to a user local bin. Okay. Now if you type EKS space version, we are getting this version. Okay. Now I need to install Helm. So Helm, just to run this one line command. That's it, right? Just to type Helm version. So this is your Helm version. Okay. Now, so what I have to do? I have to create a cluster. So to create a cluster, I have to connect to my AWS services. For AWS services, when I do for AWS configure what it was looking for, access key and secret key. So first I'll go to my AWS instance and I'll look for IAM. I'll create an access key and secret key. I'll go to my IAM service. I'll go here, my security credential, and I'll create an access key. So let me delete my existing access key. Delete. There is so many here. Okay, so done. I'll create my access key. Okay, so this is my access key. So if I'll go to my cluster server, I'll give my access key, paste it, then it will look for secret key. So this is my secret key, paste it. Now I don't want to give region, I don't want to give the output format. I have connected to cluster. Now, so what I will do is I'll copy this. The first one is access key, AKS, and this one is my secret key. Okay, so this is done. I don't want to download, which is fine. So my access key and secret key is done. Now, what I have to do is I have to create a cluster. So from this server itself, using EKS command, I can create a cluster. Okay, so what I can do is just to type here EKS create cluster, okay, hyphen name EKS01 hyphen region. Which region I want to create? I mean US East 1. You can create in any region, just I'm giving US East -1. US East -1. Okay. Then anything else? And hyphen how many node? Nodes 2. So if you just to type here, create a EKS cluster create EKS cluster using EKS-CTL command. If you type it, there's a many commands. Okay, not like there's a simple command I have used. Okay, you see, but there is a very big command. If you read this document, there is a big command. Big command means node name, all those things you want to define, right? If you so if you go with this document, see EKS cluster create. Now, so you can create a cluster using YAML file. You see, you can have a YAML file, the node name, right? SSH allow or node name to whatever things, right? You can have this. So there's a many commands, but I am going with simple one. So that this is a very simple command. EKSCTL create cluster hyphen name EKS01 region. You say node hyphen nodes 2. I need 3 nodes, 2 nodes. So like this. I'll go here. What is saying?
There's a typo there. I think the cluster you put the typo there. It shows there. CLUTSER. It's CLUSTER.
Yeah. Cluster. Correct? So now it will take you 10 minutes to create a cluster, minimum 10 minutes. If you create manually, okay, it will take 30 minutes. Okay. If you're creating via EKS-CTL, so means cloud formation template. Basically, in the backend, your cloud formation template will get through cloud formation template will run. So it will create a 10 to 12 minutes is max. Okay. So now, so let's understand this, how you can deploy your Dynatrace One agent. So there is a way, either you can go here or go to your hub and search for EKS. There's a one way, search for EKS from the hub and create, you go with the installation, which one you want to monitor. So I'll go with this. Yeah, you go to your deploy Dynatrace page, deploy one agent, and that page also has a Kubernetes cluster. It is the same thing. Okay. Not like any huge difference you have.
So the bottle rocket, right? Does bottle rocket in real time they prefer bottle rocket or they are using the EKS in real time outside?
Real time they are using EKS. Some of the
EKS.
new folks they are using, they might create with bottle rocket.
Because it's like the full stack is not there, just they need the basics of without the full
Yeah,
stack.
yeah, yeah.
Cheaper.
So you see Kubernetes, and then you can go. So when you go with this Kubernetes, right, you have to download a dynacube.yaml file. YAML file you have to download, and you have to apply your YAML file. Okay. So you see this. So this is the YAML file you have to apply. So what I can do is I'll connect my okay. So let them create a cluster. Then what I can do is either you can go from here, okay? Yeah, you go from hub. It is the same thing, just uh nothing difference, just because that is the new UI, that is the old UI. So I'm going with new UI, EKS full stack. Now I will give the cluster name EKS. What is the cluster name? EKS01, right? What is the cluster name I have given?
EKS01. Yeah.
EKS01. Network zone, right now leave it. Host group because nothing we have. Generate a token. So this is your token, data ingest token, both is needed. Then you have to download this YAML file. Now this YAML file you have to upload. This YAML file got downloaded, right? So what I have to do now, I have to open search MOBA Extreme. I have to connect my VM EC2 SSH view dashboard instance running. Guys, whoever creating a cluster, once you create the cluster, deploy Dynatrace one agent, just you go and then delete that cluster. Why? Because if you don't delete, it will charge you like anything. You can't imagine. Okay. So download. What is the DT training, right? Okay. Second. So this is my, so this mean, let me delete this existing one. My systems are very slow today. Okay. So this is my YAML file, sudo space su. I can upload this. We have options to upload from MobileStream. Okay. So you see, ls, we have that YAML file, dynacube.yaml file. So this MobileStream, we had options to download the file, upload the file from the server. Otherwise, you have to do that either as WinSCP you have to use. Okay, if you want to do that UI base, you want to use that. Then SCP command, secure file transfer command, you have to use. Okay, yeah, you can copy this file and then create a VI dynacube.yaml file and then paste all the documents, all the files, data. Okay, so now
So
let
mobile extreme is drag and drop, Ravi?
not drag and drop, upload file.
Upload.
So now you see, if I'll go to my EKS cluster, you see EKS cluster is getting created. 7 minutes is done. Another 3-4 minutes. So now you see my cluster is okay. But if you go to your compute, then see node group is not yet created. Means master got created, worker node has to be created. So it is still not yet created. So wait for few more minutes. So still we are on EKS cluster. So if you see this cloud formation stack, see the template. Because whenever you are running the command, right, in the backend, they have their own template, AWS their own template. Based on that, they'll go and execute that. So it will create everything, whatever IAM policy, everything it will be done. This template. So wait for a few more minutes. to create a cluster. Only thing is that node name we have not defined. If you define the node name, whatever the node name you have, that you can give. If you don't define the node name, then it will create a random node name, worker node name. It will create ng1, ng2, something like that. Okay, so wait for a few minutes. So now your cluster created. Now it will create their component, which is your core DNS, kubeproxy, VPC, all those things. Any questions? This command, whenever you create, right, either manually, yeah, via this command, you'll not have any issue. Just a one command, right? And then you create a cluster, deploy it, understand that what are the concept, and then you delete that cluster with these commands. Otherwise, if you create manually something you forget to delete, it will be a charging. So be careful on the whenever you are doing any creating any services on your AWS.
Ravi, work nodes will be created automatically or we need to create?
No, automatically. Everything automatically. End to end, networking, everything.
Under EC2 instance, they will create, right?
Worker node is nothing but just like EC2 instance.
EC2, yeah.
So if you go to now EC2, you might see that still not yet created, but you might see still we have only one server, which is fine. If you go to your EKS cluster, now if you go to your compute, still our node is not created. Still they need a time. So now you see EKS01 node group, EKS01 node group ng this is getting created, waiting for the CloudFormation stack. Okay. So now it will take another 5 minutes to create that. So add-on got created. Now, which is your, so we are not going with auto mode. See, EKS auto mode disabled. Resource. So now see, pods, template, nothing. So what are the components? Still we don't have pods. Then cluster, nodes, you see, any nodes you see? No nodes, right? Because still our nodes is not yet created. Still is going to create. Now see, node got created. You go compute, see, node 2, node group, everything got, still is in working mode, creating mode. Wait for a few more minutes. all the commands for this, okay, for EKS, ETL, all those things. I'll put in the document and use it, okay. If you want to create cluster something, even it in the PPT also available, but I'll put that command, okay, in the document. Just if you want to use, you can. So now cluster is ready. See, so now my cluster is ready. So tell me, when you want to connect, okay, now my cluster got created. So if you do kubectl get nodes hyphen watch, I can see that. But when you refresh the cluster, when I refresh this service, and then I want to connect cluster, what is the command? Anyone have idea? Have you logged in cluster? Now I have created a cluster, so everything is the fresh UI. I'm directly doing the kubectl get nodes hyphen watch. I can see the cluster. But however, once I refresh this, again I need to connect your AWS CLI, AWS configure, access key, secret key. First thing. Second thing is you have to connect. Anyone heard about this kube config? Anyone? No? There is a command, okay? AWS update, okay? AWS EKS update hyphen kube config hyphen region, which region your cluster. So whenever you are going to connect your cluster, okay, you have to run this command as a mandatory us-ist-1. And what is the cluster name? Hyphen name EKS01. Are you getting my point? Whenever you are connecting your cluster from your system, you have to run this command so that context that get connected, kubeconfig will get updated. Okay, so remember, now again you do that kubectl get node ns. So there is a few 6 commands you need to understand. There is a kubectl is a command, get nodes hyphen watch means you want to see the worker node. Okay, kubectl get ns. Ns is nothing but namespace. Okay, you see, right? This is your namespace, and namespace is nothing but just like a project folder. You create one folder, right? And then you put all the data, right? Same way, you create a namespace. Inside the namespace, you go and whatever things you want to deploy, you deploy that. If I delete that namespace, the entire thing's gone. You understand that? Suppose I have created one folder here. Okay? Created one folder. Okay? Now all the data I move to that folder. Example. Okay? Control X. And I have created this. I move this. Now tell me, if I'll delete this folder, entire data gone, right? Yes or no? If I'll delete this, entire data will be gone. Under this, what are the files were there? Same way, if you create a namespace, inside the namespace, whatever the application, whatever things you wanted to deploy, you go and deploy. But if I'll delete the namespace, then it will deploy everything. Now, suppose this application used by somewhere. Now this application is used by somewhere. Then if you delete this folder, will that delete everything? No, it will not delete everything, right? This will say, no, this file being used by this application. Thus you go and stop this and open this system. Suppose sometimes your word was open and you are trying to delete, it was not getting delete. Why? Because that file was open. Same way that application is something. So you need to stop the service something and then you delete that. That is the best practice. Okay. So whenever you delete, all the configuration will get deleted. Make sense for everyone? For
So namespaces is like name of number of projects or number of application names which are
So
on
whatever the application you are going to deploy, you will define for that application, define the namespace, and then we deploy that. Suppose I'm going to deploy one agent, I'll create a namespace which is called Dynatrace, and then under the Dynatrace I'll deploy one agent. Okay. So now what I have to do is I have to create a namespace. So kubectl create namespace which is Dynatrace. So let's go to that command. So what is the thing? Namespace Dynatrace. I'll create that Dynatrace namespace where we have namespace Dynatrace. Okay, so got created. If you do kubectl get ns here namespace is short form, Dynatrace got created. So now this I need to run this command, right? To run this command, namespace already I have created, right? So what I can do is either I want to run command in one shot, directly I'll go and run this. So help install create namespace and run this. Yeah, you need to remove this. Create namespace part, you have to remove this. So if you want to either you remove here, yeah, you delete here. So either you want to delete kubectl delete namespace Dynatrace. Got deleted? Okay. Now I will go here, copy this command and go to your server and paste this. If you are running from your command prompt, then this slash will not work, hyphen. Remember? Okay. If you are running from Windows server, okay, Windows server, your command prompt you are running, then directly copy paste will not work. You have to run in, if you are running from CMD, then it will run as a hyphen, space hyphen. So you see, it is pulling that. So Helm is a package manager. So from that Dynatrace with the help of Dynatrace operator, that agent will get deployed. So suppose now you have a 2 worker node. Suppose you scale to 4. So that another 2 server, how the Dynatrace one agent will get deployed? That is your Dynatrace operator will take care of that. Okay. You understand that, right? Operator means now, suppose now you have a 2 worker node, another 2 worker node got added. Example, you scale your environment. Then what will happen? Dynatrace operator will automatically, when that application is getting scaled, one agent will get deployed automatically. Okay. So that who will take care of that? Dynatrace operator will take care of that. Okay. So now this got deployed. So now we have ls, we have dynacube.yaml file. So I'll go here and apply this. Apply f dynacube.yaml. Got created. So now kubectl get pod. So I want to check the pod, right? So get pod -n under which folder? Means under which namespace? Are you getting my point? Which is your Dynatrace. You see, all are running state. So now all are in running state. If I'll go to my here and still my cluster is getting connected, which is fine. Yeah, go directly to cluster list. Open a new tab. Now you see cluster came. So this is your EKS table. Now you understood how you can deploy Dynatrace one agent on EKS cluster. It is very simple. There's only 4 commands. You need to connect your cluster. You need to create a namespace. You need to run this command via a Helm package manager. You need to install that. Okay, and then you need to apply the dynacube.yaml file. So if you see this YAML file, okay, cat dynacube.yaml file, nothing have name. What is the name? Cluster name. Namespace Dynatrace. Opaque means other services. API version this, which Dynatrace was given. Kind Dynacube. Metadata, EKS name, cluster name, namespace, automation this. Okay, and the Dynatrace URL with the help API, Dynatrace API URL, all those things, and that's it. Then you have a CPU limit, memory limit. That's it. Right? So now if you go here, still that is fine. Now you go here. It will take time, 5 minutes minimum, to get all the data reflected. Okay. So now if you see this, when you install this, right, this, so what is happening? You see, Dynatrace operator got installed. You see, thank you for installing Dynatrace operator. So now we are installing Dynatrace operator, and whatever the worker node we have, on that node, agent will get deployed. So now we have a 2 worker node. Now we'll have a 4. Again, we'll after 1 hour, when your application has too much traffic, your application scale up, then it require another 2 worker node is getting added. So operator will go and install that. You are not going to install again manually. Operator will take care of that, which is your Dynatrace operator. Okay. So now you see this. Still data is coming up. If you see this host classic and refresh it, your worker node also will be coming up. See, 2 worker node got added. Now so see, one cluster has a 2 nodes is coming up, but still data not yet came. Now namespace. So there is a namespace. So still the data is coming up. It will take time. Okay. So meanwhile, let's deploy the application also. So I will show you that how you can deploy your application. Okay. ls. So to deploy the application, I am deploying which application? I am deploying EasyTrade application. So I will create a namespace. So every time, whenever you are doing anything, you have to create a new thing. You are deploying something, you have to create a new folder. Okay. So kubectl create namespace, which is your EasyTrade. Okay. So namespace got created. So if you do kubectl get ns, you see my EasyTrade namespace is there, which was created 7 seconds ago. Now I will clone this. So GitHub EasyTrade. Copy this. And I will go here, git clone, and use this. So git is not found. So what means I have to install yum install git Okay. Now git clone ls cd trade ls where I should go cd Kubernetes manifest file ls cd release. There will be a service, right? Where you need to see the service. So all the services here. So now I need to, so now I want to apply. So when you are doing Docker Compose, right? What you are doing? Docker Compose -up -d, right? Everything is getting created, right? Now, earlier we had how many files for Dynacube? One file. So you gave kubectl apply -f dynacube.yaml file. Am I correct? Yes or no? For Dynatrace, what file you have given that command? Remember? One file. So you gave that YAML because one service you have. Okay. Now you have here 10 service example, right? You have account, you have connection, engine, front end, offer service, third party, pricing, problem, RabbitMQ, manage. There's a many service. So now I want to apply all the service in one shot. What we can do? There is a command kubectl apply -f and then you put a dot. Then -n and EG-trade. Okay. You apply this. You see, everything got created in one shot. So now I want to check the pod. Pod is running means container is running. kubectl get pod, multiple pods. So pods -n and EG-trade. Okay. What is the problem?
I think get -n pod, I think.
kubectl.
No, there is a spell mistake of kubectl.
Now it could be fine. So now you see all are running. One is pod initializing phase, which is your DB. Take time. Okay. So now I want to expose. So what I will expose is front end, right? So kubectl get SVC. SVC means service. Okay. Front end reverse proxy -EG-trade. Okay, -n and Dynatrace.
I guess after front end, there will be space required, right? Not required.
Let me.
After front end, space reverse proxy.
I got this. External IP. Copy this. Because YAML file already done. Okay. So copy this. Go here. Right click, paste. Hit this. You see your EG-trade is coming up. You have to expose that front end service. That's a reverse proxy service. Okay, whichever things. Okay, I read the document, that is the region. So you have to expose this. That's it. Right. You see, I have done that. So there is a way you can deploy. Still your data takes time little bit. Okay. So now data is coming up properly. You can do that. Okay. So this is the way you can deploy. Okay. Now suppose you want to restart something, yeah, something like that. So you cannot do like restart everything. You need to roll out. Okay. And then roll out, restart deployment, and complete deployment itself. You can do that, all those things, changes you wanted to. Okay. So this is the way. Now if you go to your cluster and if you see this, now you see EG-Trade got added, workload got added, right? Now if you go to your service, Dynatrace UI is very, very slow on the trial environment. So you see service got added. So on the cluster, application restart is needed. Tell me.
Yes.
No. How?
Oh, sorry, this is Kubernetes, right? Yeah.
Kubernetes cluster application restart is not needed.
Not required. Yeah.
Not required. So that is one thing. Then lot of things, right? So you can manage that. So now you should deploy and forget. That's it. So your service is coming up. So there is a dashboard, okay, which you have Kubernetes dashboard, okay, where you can see all the data, but the still data is popping up. It will take time little bit, but after that 5 to 10 minutes you need to have a wait. You need to wait and then you can see your data.
So any patching or anything happens, or maybe any upgrade happens in the one agent, Dynatrace one agent, that time does it require any application restart, or it just because it's in a cluster mode in Kubernetes, it doesn't require?
Doesn't require.
Okay.
You made
So
it say only anytime it's not required?
No, on the Kubernetes cluster side, one agent restart is not needed.
Actually, we had a situation like a while ago. They did the upgrade, and the technology stack was not supported in the Kubernetes environment. So this
Now
cluster was
sometimes your one agent is very older and that it is not supported. You need to upgrade your agent. That's it.
no, after the upgrade, it did not work. So they had to roll back.
So now
during
see,
that,
so sometimes you have to roll back, roll out, and complete deployment, and then you need to deploy again. Okay. So this is your dashboard. You see a small dashboard for Kubernetes, for Dynatrace. This is for node. This is for cluster CPU utilization, CPU request. So CPU request in the Dynacube YAML file, how much you have seen that limit? Okay. So all those things, so request limit, all those things. This is your memory utilization. Okay, and how many namespace you have. This is your default namespace kube system, and this is your kube system. Okay, so now if you go to your another dashboard, which is your node pods, even you can create a vibrant dashboard on beyond that. This is the default dashboard that Dynatrace was given based on the DKL query. So this is your another dashboard which has 2 worker nodes. So this was a variable. Okay, this is this 2, right? It is a variable. If you go here and if you clone this, okay, if you go and duplicate, because I cannot edit that because default dashboard, I can duplicate and then I can show you that. So this is your you see, right, variables. UI is very, very slow. You see, right, cluster variables. So fetch DT integration, fill into name ascending order. So this is your variables. Then you have cluster variable, then you have a node variable, then you have a node ID variable. Okay. Always fetch the data for last 2 hours in the dashboard. You can expand as your wish, but always fetch for data for last 2 hours. So now cluster, if you go overview, so now you'll have all the data. So now see one workload having an issue. So this is your cluster information. Now if you go namespace, so what are the namespace you have? These are the namespace. This is your workload. So see, content creator was having an issue. So what is the issue now? Back off event getting down. So this is getting because pod is getting down, okay, because of the out of memory or something. So this we have then, or apart from that, everything is running as expected. Okay, so these are the situation where you can see your deployment. You can see your this is your all deployment. This is your daemon set, a stateful set. If you have then replica, if you have created any replica, I have not created any replica, so that's fine. A replication controller, but if your replica you have, then only you can talk about replica. This is your jobs. Any jobs are running. There is no jobs are running. There is no cron job is scheduled. So nothing we have. Other workload. Nothing. Then we have a pods, which is your inside that pod. We have a containers. All pods. Then we have a service. Okay, and then you have a containers. Understood? So that's how it works. Okay. So any questions? So how you can deploy Dynatrace one agent on the cluster, all those things? Nothing, right?
So
Ravi,
like,
Yeah, go ahead.
Ravi, if we deploy another application, suppose pet clinic, so will this become an shared environment, or that
No.
concept is different?
No, that will not, because one cluster, right? Not only one application, many applications would be running. Okay, but you can say that is a shared environment, because suppose now you want to monitor only one application. Okay, but you deployed Dynatrace one agent cluster, so cluster will get monitored, node will get monitored, but that on the service side, what you can do is you need to create a rules such a way that so in under this namespace I should not monitor something like that, but it called as a shared environment for sure. So all the applications, suppose you have a two application like EasyTrade, we have a dev prod, right? So dev has a two environment, like a development environment and QAT environment, yeah, QA and non-prod environment, whatever you say. We deployed on one cluster, both the non-prod server, non-prod application, and under the different namespace, but production you'll have only one. Okay.
how would you decide like if the application is really big one? It's like so based on the cluster which we are installing, right? We are using the generic or the standard infra in there, infrastructure, the CPU, memory, and all that. But how do you decide like if it is pretty huge application with so many? I think here we are talking the application is nothing but the workloads, right? Under the
Yeah.
namespace is the project name. So here
There is a
that
workload.
workloads.
So,
Okay, and therein, I'm sorry.
So how you can understand what kind of infrastructure is needed, right? Infrastructure means worker node. How many worker node is needed, right? So basically, you need to understand what kind of components you are installing. Okay, how many services they do have, how many database they do have, what kind of database scaling they do have. All those things we need to understand, and based on that, it will go and create that. So when you create a cluster, right? So now we have two worker node. I am not scaling an environment. When you scale that, suppose you take that, okay, application little big. Okay, so I'm taking worker node 4 virtual CPU, 16 GB of RAM. Okay, yeah, 4 virtual CPU, 8 GB of RAM. You will come to know that when you cluster memory utilization, when you use 4 virtual CPU, 8 GB RAM, which has a 3 worker node, yeah, 4 worker node. Now you see that cluster memory utilization. It is consuming almost auto. You are getting any pods are getting down because of out of memory error, because there is no space on the application, so that you can go and scale your environment. Okay, basically that's how we are deciding.
So the only major difference between the Docker and Docker Compose and here in the Kubernetes, we are using there it is stated as microservices or the applications inside it in a project, and here we are using the namespace as a project name. Under the namespace, the applications are the workloads. Correct?
Correct.
Okay.
Okay, any questions? Gajala, Vashu,
Um,
Manoj.
Ravi, we normally if we want to connect these work nodes and all, we use AWS CLI, right?
Even see, when you create a cluster, right? So there is a two way. You want to log in your you want to log in or worker node or not. So if you enable, then yes, you can log in. If you have not enabled, you cannot log in. Suppose I have EC2 instance right now.
Mm.
If I'll go to my EC2, whether I can able to log in, because I have not enabled this server, I cannot log in. But when I'll give the command, yes, I can log into that worker node also. Then worker node login enable, yes, no, all those things. Then you can enable, disable this. So this server, right? Which PEM key I should log in? If I log in, suppose let me check this. So root user, try whether I can log in. Yes, I can log in. Even AWS CLI, yeah, directly you can log in from this. Let's see. See, I'm not able to log in because SSH connection was not established during the server while doing the creating the cluster. So I cannot log into this cluster. So when you create a cluster, so in my YouTube, right, there you can see there is a video. You create a cluster manually. Okay. So there we have options like I want to log in worker node, all those things like that options you have that.
Mm.
Okay, like you want to the log into the cluster when you create a worker node. So let me see here, cluster compute.
Actually, what maybe I'm you understand or not? I'm not sure. Let me repeat one thing. So normally we local system we install the AWS CLI and we use AWS access key and secret key, right?
Hmm.
We can access from local machine, right?
Everything, even I can log in, I can connect to my cluster with my personal system. Like,
Mm-hmm.
okay, so to connect to personal system, I will open my CMD. Okay, let me show you that. Okay, see, first what I will do, AWS configure.
Configure.
I'll give AWS access key and secret key.
Yeah, yeah.
Okay, so let me give that access key and secret key. I'll show you that.
So from here we are connecting, right? So to connect locally, we are using this option, right?
No, even you want to connect your cluster,
Mm.
you have to go with this option only. If
Okay.
it is a Azure CLI.
Mm.
If it is a Google Cloud, there is a Google Cloud CLI. You have to install it. Then
Mm.
only you can interact. Once this is done, right? Then
Mm.
I have to run this command. AWS EKS update kubeconfig update. Once you do that, then your ARN is get updated. And now if you type kubectl get ns, just you see, I'm getting that. See. So remember to connect your cluster from your local machine to cluster. For you, the mediator is AWS CLI.
Okay, that is what that is the doubt for me. So to connect locally, we are using AWS CLI, right? Okay.
From anywhere, you have to connect your cluster. CLI you have to use.
Within AWS, we are connecting. Is it there also is required, right?
Even if you are connecting from AWS itself, then you can use the AWS Cloud Console, Cloud Cell.
Okay.
You see this? Even Azure has Azure Cloud Cell and Kubernetes has a Kubernetes.
Where this option, Ravi? I am not.
You see this. You see this.
Okay. Bottom. Okay. Top. Okay.
Okay. Now here also, if I'll connect, right, which service I want to connect? So tell me, what are things I need to use using Cloud Cell? Again, AWS configure. Yeah, I need to update this kube config, and then you need to try.
Within here also, when we're connecting here, we need to give AWS access key and security access key, right?
No, that is not needed because you are in this
within AWS.
TL get ns. See, so at least this command you have to get. This command you have to use.
Okay. Which region it's connected?
Which region, what cluster name, then it will update your configuration, kube config, and then you can connect to your cluster.
So
this is your Cloud Cell.
We don't need to go like AWS EKS -- region EST update kube config -name EKS. Those the long command is not required because
this command is needed.
Yeah, okay.
This only AWS CLI, AWS configure, access key and secret key is not needed. Okay. Because you are in the Cloud Cell itself, right?
Okay.
So that is the region. It is not needed. Otherwise, you need everything.
Yeah. Got it.
So it's like we are in the session, right? So it's not needed since we are already in that login session.
We are in that session. You are in this Kubernetes, right? So that cell was from EKS itself, that cloud itself, right? So now you can interact with service. Just which service you want to interact, that service details you need to update, right? And then you need to try, no?
I think when we exit out of that, I think whatever I think Vasu was telling might work, that the secret key and the pass key.
Not
secret key and pass key for AWS CLI is not needed. Cloud Cell is not needed.
We connect from local machine, right? It's required.
Local machine. Even this is my, assume like this is server is my local machine. Okay. From this server, I'm trying to connect. Same way from my personal system, I'm trying to connect. Same way. You see this, right? So I need to update this config. Otherwise, if you don't do that, it will be updated. Now another cluster I want to create, another cluster I want to connect. Again, I need to update the config, which has a secrets, so that your key value will get updated so that you can connect your cluster. Otherwise, now I want to connect EKS cluster 02. I cannot directly try, right? Keep serial get. So which cluster you want to connect, which region? Then you need to update their configuration so that it will get updated, and then you access your cluster. If you want to go inside room, right? Which room you want to go, right? For that, you should have a control, right? Whether I can go or not. Okay. Otherwise, you cannot go if you have a 10th floor office and you are sitting on 7th floor.
We have access, go
which floor you have access? That floor only you can go, right?
Yeah.
And if you are going that, right, you have to give that access key, no?
Yeah, exactly.
So that access key is needed, which then you give the justification. Hey, my name is Vashu. I belong to this. This will get updated. You see, yeah, this is the correct guy. Okay, let them enter. Understood?
Yeah. From local, when we are connecting from local, we can do modification to our local from our local itself.
Local itself.
Yeah.
Because you need to update the config, which has a metadata, which has a secret and passwords.
Yeah.
If you don't have passwords, how you can connect? Tell me.
Yeah. No. If we want to do any changes, we can do from local machine itself, right? Once we connect.
Every time you used to connect. See,
instead of connecting from AWS.
This server, why I have used, what are the prerequisite has to be installed, how you can install. That is the reason I have shown you, right? In my local system, everything is installed. You understand that?
Yeah.
That is the reason I have used one server. Okay.
Yeah.
Otherwise, I would have installed in my local system. Okay. The thing is already installed, configure environment, variables, everything, right? That is the reason I am not using them from my personal system. Okay. It is looks like you need to think like it looks like personal system only, but I'm using because in Windows, once you install everything, you have to configure as an environment variable. You understand that?
Yeah.
You remember when you're installing Java, then you need to configure
Yeah.
Java environment. You can call from
Variable.
anywhere, right? Just you type Java hyphen, otherwise you have to give the path. But
Yes.
so that is the reason I have not used my local because already installed configure, but that is the reason I have used this jump server where you can install all the systems, all the prerequisite, and then you install your cluster. Okay.
Okay.
So that's it for today. Any questions?
Ravi, can you please explain me about that shared environment once again, please? Because there was one use case wherein they were asked like they had this Kubernetes, which is in shared environment, okay, and they want to monitor some of the services basically, and not the
So what?
entire.
So what you can do is go to your Dynatrace. So what are things you want to monitor, right? And you don't want to monitor, go to setting. Okay. You have to create a certain rules under this namespace, do not monitor, something like that. Because you have suppose 2 container, right? So now you need to monitor process group monitoring. Okay. Built-in detection process group monitoring.
Can you show me where exactly to navigate it?
You are not seeing my screen?
No, it's not. Screen is not changed.
Okay. So now enable automatic. You see here cloud or workload detection. You see here somewhere in the, if you go here, there is a rule you can create, add a new rule. Okay. Because everything work as a namespace. So namespace name based on pod name, based on container name, based on the stage, based on project equals, and namespace name. Suppose I am giving EG trade. EG trade. Okay. Where we have do not monitor, somewhere we have option. Namespace name. Suppose hotel. Okay, this is we don't have container monitoring rules. No container monitoring rules. Add item. See, do not monitor, you see, right? Container name begin with condition. Okay, you can give that. Okay, container name. You can give that one thing. Second thing is, and then you give this container god, then whatever the namespace you create here, add a rule because you have given namespace exist and then you monitor that everything, right? You see this. You monitor exist, you monitor that. Again, you create a rule and you don't monitor, you disable this. That's it.
Yeah,
You understand that?
yeah.
Okay, and built-in container monitoring rules. Okay, so we can't do anything because in the one you want to monitor, but here you need to create a rules. Okay, and then you don't monitor that. Okay, so that option we have. Apart from that, we don't have. Okay, service detection rules. Okay, so here also is service when you don't want. So that is on the container side. Okay, now service side. So service rule name, match value, cluster name, whatever things you give. Then template you have, your service name you have, and then advanced service detection, whatever things, add item, whatever the item you do, and then you you create that, and then you don't monitor that. You create a rules. Once you enable, and then you disable it, so that it will get disable that service detection. But here is the detection rule. It's not like you cannot after that you think like you will have options to if you add item, right, you need to add the attributes key. You see this. So now if you disable this workload name, so now you give that Kubernetes DT workload name is not null. You need to give the condition, do not monitor. Okay, and then so that it will not get monitored. You need to give the matching condition, like it should be on this name, and then do not monitor. Okay, then you need to give that workload name DT dot all those template, and then you need to decide, and then you disable it. So you give the condition itself. This service name belongs to this. Yeah, workload belongs to this. You disable this. So you have a service naming rule. Understood that?
Yes, right. Yeah.
Okay. So there is a container, there is a service. Anyway, infrastructure you have to monitor, host you have to monitor because you have a shared environment. Okay. So that's it for today. Okay. So we'll catch up on Saturday. Okay. So Saturday